I used to ask this question from our participants, from our trainees, whether they know or whether they can express with very, very short sentences what's the difference between safety and security. And what I had to conclude, and what was the easiest way to tell them, that safety is when we are protecting the humans from a system, and security is when we are protecting the system from humans.
I love this definition. I really love it. It's a good one. Thanks for sharing, Zoltan. I
Yeah.
love it. So it's a very good and wide question. So I will try to answer, I would say, with my knowledge of the industry, and I hope Zoltan will complement that. So I would say the secure coding practices, that source, I would say, first at the cultural level. So you need to have people who are aware of the cybersecurity concerns. So which are the assets that you want to protect and which are the threats that you are facing. You need to start that. Then the persons who are going to specify the system, the architect, they need to be aware of that. So because if none of the guy or gals specifying the system is aware of the cybersecurity concerns, definitely you will be in trouble. Then that somehow gives some requirements to the developers, and the developers themselves have to have some, I would say, awareness about the culture. So I would say there's a cultural aspect that you cannot avoid. I would say this is a kind for me of a prerequisite. Then once you have this cultural aspect, indeed, you need some tools to enforce the rule you mentioned. So for instance, we talked about buffer overflow. So you should test that you have no buffer overflow, which means typically using sanitizers such as Valgrind or Purifine or UBSAN is a good idea, because you are going to detect not all, but some of the undefined behavior. And definitely, this is very important. Also, then you can, so that would be more kind of a dynamic testing. Then if you go to more, I would say, static things, you are going to be able to address a wider scale of possible cases. And you can go up to a full mathematical proof. It can be more costly, but the benefits are huge. And also, I would say something you have to forget is it's not because like 2 years ago you get a training on secure coding and something like that, that now you know everything. The field is moving so fast that you constantly need to keep up with the pace and learn new things. So even if you just finished a project, you did something which was good. So where are you standing now? Which are the new threats? Which are the new exploits which are happening on the field? So you need to keep to and be informed, I would say.
Yeah, thanks for mentioning the everlasting learning, the curve of programming and coding. And maybe it will be a little bit surprising, but I used to say that there is no such thing as secure coding, because you can have just coding which may have vulnerabilities or deficiencies or security flaws or maybe special conditions in which those particular codes will behave unexpectedly or in an unspecified or in an undefined way. So that's why whenever a programmer writes a code, what he can maximize is his learning capabilities. So if there's a tool which will warn you that, okay, what you are writing will do actually the job, what you are about to do, but actually it will also establish a possibility for an attacker to exploit it. And that's why whenever you are writing your code, you are continuously learning, because when you are implementing something, you are focusing on what you want to reach. And secure coding is about to think about what others can exploit with that code. So how things can go wrong. So that's why you have to focus on two issues: the normal behavior and on the abnormal or malicious behavior of the same code. And that's make it on one hand difficult, but on the other hand makes it very interesting.